In today's session at Medical Sciences Made Easy, we want to discuss about calculating or converting units from first principles. And today we want to see how we can convert different analytes or from different units. We're going to see how we can convert milligrams per deciliter to grams to millimoles, and also converting milligrams back to millimoles. This is what we want to discuss. And this is always common in our exams, and even we can apply them in our laboratories in the hospital. So let us always, we're going to learn how to calculate them from first principles, converting units using first principles. And we always remind you to subscribe, share your comment, and always like the video, which will always energize us. And in today we have two questions. We want to see how to convert 200 milligrams per deciliter of glucose to millimoles per liter, and we shall also see how to convert urea, 10 millimoles per liter to milligrams per deciliter. So I want to start with number one, whereby we are beginning with number one, where we are converting 2 milligrams per deciliter of glucose to millimoles per liter. So we are taking it to millimoles per liter. And this milligram, we have to, the first procedure is to convert milligrams per deciliter to grams per liter. So we are going to see converting this to milligrams. So we have the first step is to convert milligrams per deciliter to grams per liter. Why are we converting to grams per liter? Because we want to look at the amount of this glucose in 1 mole. And 1 mole is always in 1,000 mils, which we call 1 liter. So, and we know that 1,000 milligrams always begin with what you have. Don't begin with grams which you don't have. Always begin with milligrams which you have. And we know that 1,000 milligrams are equivalent. So we are beginning by converting 200 milligrams. Is equivalent to 1 gram. So what about 200 milligrams? Then we cross multiply, which will be 200 milligrams, and always maintain units over 1,000 milligrams. Then this milligram will go with this milligram, and we shall remain with, we are seeing 2 zeros going together, and we're remaining with the 2 out of 10, which is 0.2. 0.2 grams. So we are seeing 200 milligrams are equivalent to 0.2 grams. Then after seeing this one, we need also to convert a deciliter into a liter. And we know that we are converting a deciliter into a liter, and we know that 1 liter is equal to 10 deciliters, or what we can say 10 deciliters is equivalent to 1 liter. So meaning where there is a deciliter, I'm going to replace it or to substitute it with 1 liter. Then I will end up by saying that 200 milligrams per deciliter is equivalent. Where there is 200 milligrams, I put 0.2 grams, and where there is deciliter, I put 1 liter. But before that, we know that this is a deciliter, not 10 deciliters. So what we are going to do is to make the deciliter the subject of the formula, which is going to be divided by 10 deciliter divided by 10. And after dividing by 10, we shall remain with 1 deciliter equivalent to 0.1, or what we call 1 liter out of 10. So meaning we are going to replace where there is a deciliter with 1 liter out of 10, or what we can call 0.1 liters. So we're going to replace this one. So we're going to say 200 milligrams per deciliter. Per 1 deciliter is the same as, per means divided. is the same as where there is 200, we put 0.2 grams, and where there is 1 deciliter, we replace it with 0.1 liter. And this we shall end up having, this is the same as 2 out of 10 divided by 1 out of 10. And we shall get 2 out of 10, then we remove the division sign, where we take the reciprocal, and 10 goes up. Then the 10 will go with 10, and we shall remain with 2 out of 1, which is the same as 2 grams per liter. So therefore, 200 milligrams per deciliter of glucose is the same as 2 grams per liter of glucose. So this is the first step, converting milligrams per deciliter to grams per liter. And after getting this into grams per liter, we have to calculate the RFM, or what we call the relative molecular mass of glucose. And glucose, its formula is C6H12 and O6. So calculating its relative molecular mass is this. We know that carbon, the atomic number of carbon is 12, so it is going to be 12 times 6, plus hydrogen has atomic number of 1, which is times 12, then plus oxygen, which has atomic number of 16, and we multiply by 6. So this is what we are seeing. We are calculating the relative molecular mass of glucose. And this relative molecular mass of glucose, 12 times 6 is 96, then plus 12, then plus 16 times 6, we can calculate it together, whereby 16 times 6 is 96. This is 96, whereas 12 times 6 is 12 times 6 is 72. And when we add all this, when we get 72 plus 12, then plus 96, we get our 180. So we are getting 180 as the relative molecular mass, 180. And since it is relative, we don't put a unit. So this is the relative molecular mass of glucose. And after getting, we have already converted to grams per liter, and we have got our relative molecular mass of glucose. And we know that this relative molecular mass is in 1 mole. So if 180 grams of glucose are contained in 1 mole, if they are in 1 mole, what about the 2 grams? Because mole means per liter. What about 2 grams of glucose? So the 2 grams of glucose will be contained in, then we cross multiply, whereby this 2 is going to multiply with 1 mole, then divided by 180, which is 2 grams times 1 mole, you divide by 180 grams. Please always maintain the units. Always maintain the units. And this was step 2. Now we are on step 3. Step 3 is we are calculating the moles. If 180 grams of glucose, which is the relative molecular mass, is in 1 mole, what about the 2 grams? Then when we get 2 divided by, if this is 2 by 1, this is 6, this is 9, So we are getting 1, then the gram goes with the gram, we are getting 1 mole divided by 9. And this one will give us, if we get 1 divided by 9, we shall be able to get 0.11, which is the same as 0.111 moles of glucose. So we are saying 2 grams in a liter of glucose, in a liter of solution of glucose contains 0.11 moles of glucose. So after seeing this one, the last step is now to convert moles to millimoles, because the question wants you to put in millimoles per liter. So the fourth step, which is step number 4, is we are going to convert 0.11 moles of glucose to millimoles per liter. And we know that we always begin with what we have. Since we have moles, we shall begin with moles. And we know that 1 mole is equivalent to 1,000 millimoles per liter. So if 1 mole is equivalent to 1,000, what about this of glucose which we have? What about 0.11 moles of glucose? Will be equivalent to 0.11 moles times 1,000 millimoles per liter. We cross multiply this times this, then divided by this, divided by 1 mole, and mole will go with the mole, and we are remaining with 0.111 times 1,000 millimoles, and this one will give us 110. We are multiplying by 1,000, and this one will give us 11. Hope we have calculated it well. This was out of 90. This is 90, so we get 0.11. And here we are converting 0.011, and here still we are getting 0.011. So we are multiplying here by 0.011, and still here it is 0.11, and we get the answer as 11.1 millimole per liter of glucose. So that is what we are getting. So we shall conclude by saying therefore 200 milligrams per deciliter of glucose is equivalent to 11.1 millimole per liter, and we conclude our calculation. So converting 200 milligrams per deciliter of glucose to millimoles, we have found out that 200 are equivalent to 11 point, and after getting this answer, we can always check it by dividing by 18. Just when you get 18, when you get 200 divided by 18, you can check if you are right. And when we do it, we find that it will give us 11.1 millimoles per liter. So we have done it in 4 steps, whereby the first step is always to convert milligrams per deciliter to grams per liter. And after getting it, the second step is you get the relative molecular form, and when you are doing it, don't hide this, because this one also takes marks. Always put it in the solution. Then after getting the relative molecular mass of that substance given, you now you calculate if this one is in 1 mole, what about the grams which you have got here? Then that is step number 3. Then number 4, which is the last one, is because we need it, you have got moles, but we need in millimoles, you also convert these moles to millimoles and you get your answer. Then after getting your answer, you can always check with the conversion factor of 18 if it is glucose, because the glucose conversion factor from milligrams to millimoles, you divide by 18. So this is what we say from first principles without using any formula. So always do it from first principles. And we can also ask you to convert this 11 back to milligrams. So you do backwards, as we are going to see it under an example of urea. We're going to do it under example of urea. And under urea, which is the question number 2, they're asking us to convert 10 millimoles of urea to milligrams per deciliter from first principles. And we shall begin by converting the first step. The first step here, step number 1, is to convert 10 millimoles per liter of urea to moles per liter, or you can even leave it as moles. And we know that since we always begin with what we have. Don't begin with the moles when you have millimoles, to avoid things of bringing in X. So we know that 1,000 millimoles per liter is equivalent to 1 mole per liter. What about the 10? 10 millimole per liter will be equivalent, we cross multiply, whereby we get 10 times 1, we divide by 1,000, and this one shall give us 0.01 moles in a liter. So so we have converted 10 millimoles of urea to this. This is of urea. So that is the first step. After converting millimoles to moles per liter, the second step will be to calculate the RFM, calculate the relative formula mass of urea. And urea is always, this is the formula of urea. So meaning to calculate this relative molecular mass, we see it has two nitrogen, and nitrogen, the atomic number is 14, then we multiply by 2, then plus hydrogen atomic number is 1, but this is 2 times 2 is 4, so we get 1 times 4. Then plus carbon, which has the atomic number of 12, but it is 1, so we multiply by 1, plus oxygen, multiply it by 1. And the end result, we shall get 60. But since it is relative formula mass, we shall not put gram. So this is the second step under this conversion. And after getting this relative formula mass or relative molecular mass of urea, the next step, which is step number 3, is that these ones are contained in 1 mole. So if 1 mole of urea contain 60 grams, what about 0.01? What about 0.01 moles of urea? We cross multiply this by this, which is 60 grams times 0.01 moles divided by 1 mole. Mole goes with the mole, and we shall remain with 60 multiplied by 0.01. And when we get 60, if we can calculate it together, you get 60, you multiply by 0.01, we get 0.6 grams. We are able to get 0.6 6 grams of urea. So this 0.66 grams of urea are the one that is in 0.1 mol. That is step number 3. Then the last step is now to convert, and these grams are in a liter. Moles means in 1,000 mils. So this one is grams per liter. They are in a liter. So the last step we shall need to do is now to convert grams per liter to milligrams per deciliter, since the answer is needed in milligrams per deciliter. So the last step, which is step 4, is you convert 0.6 grams per liter of urea milligrams per deciliter, and we know that we first convert 0.6 grams, and we know that since we have grams, we begin with grams, and 1 gram is equivalent to 1,000 milligrams. What about 0.6 grams? It will be equivalent to 0.6 times 1,000 milligrams. You divide by 1 gram, gram goes with a gram, and you remain with 600 milligrams. After getting that, we also convert 1 liter to deciliter. Convert 1 liter to deciliter, and we know that 1 liter is equivalent to 10 deciliter. So here where there is a liter, we are going to replace it with 10 deciliter, and we shall conclude by saying that 0.6 grams divided by 1 liter, that is what it means, is the same as where there is 0.6 grams, we put 600 milligrams. We divide where there is a liter, we put 10 deciliters. In 10, we will go with 10, and we shall get the answer as 60 milligrams per deciliter. So here, after getting this, you conclude by saying that 10 millimoles per liter of urea is equivalent to 60 milligrams per deciliter. And that is the final answer. So it is always done in 4 steps. So when you're converting from millimoles to milligrams per deciliter, the first step is to convert millimoles to moles. And after getting these moles are in a liter or in 1,000 mils. The second step, you calculate the relative formula mass of the substance given. So you always see the substance given, it will determine the molecular mass. And after getting the molecular masses are always in 1 mole. So if 1 mole contains these grams of the molecular mass, what about the moles you have? You get the answer. Then the 4th step is always to, since they want it in milligrams per deciliter, now we convert grams per liter to milligrams per deciliter. And this is how we can always answer this. And I want to give you exercise which will give answers in the inbox, whereby you shall go to the comment section and you tell us the answer. And the question I want you to do as exercise, I want you to exercise whereby I want you to convert 5.0 millimoles of glucose to milligrams per deciliter from first principles. These we are using first principles, and you will be able to inbox me the answer. This is exercise 1, and exercise 2. I want also to convert. You can convert 40 milligrams per deciliter of urea to millimoles per liter. So this is the exercise. You can inbox me the answer after doing it. This is the exercise. Convert 5.0 millimoles of glucose to milligrams per deciliter. And I also want you to convert 40 milligrams per deciliter of urea to millimoles per liter. Thank you so much for being with us until the end. Always remind you to subscribe, like the video, and share your comments. Thank you so much.